It's the SDG Podcast. Before we get started, you can check us out on the web at solutiondesign.com/podcast or find us on all the social medias, LinkedIn, Twitter, Facebook, and Instagram at Solution Design Group.
Hey, everybody. Welcome back to the SDG Podcast. I'm Peter Lawrence, and podcasters, you want to introduce yourselves?
Hey, I'm Chad Jetner.
Okay,
I'm
and
Eric
today
Schneider.
we've got, go ahead, Eric, again.
Sean.
Oh, sorry. I'm Eric Schneider.
I'm Singy Shaw.
Yeah, our two special guests talk about DevOps. And I mean, for real, the first big question that everybody wants to know is, what is DevOps?
DevOps, a cultural shift towards software development and software delivery with its own set of practices and principles and philosophy.
Holy cow.
to follow.
He's not even reading it, folks. It's like he's memorized it. That's awesome.
Are you on Websters.com right now?
No, I'm staring at you guys right now. Yeah, something around that definition.
I think it sounds like you've answered that question once or twice before.
Yeah, because having to explain what a DevOps engineer to people is quite difficult. So I just call myself a cloud engineer or a jack of all trades.
That's a helpful skill set to have when you're doing DevOps. How about you, Eric? Do you share the same definition?
Yeah, I think it's important to distinguish between like saying like where a DevOps engineer typically is somebody who is a jack of all trades. I mean, they've usually worked on operations, managing servers, that kind of stuff, but also touched development to some degree typically. So they've existed on kind of both sides of that paradigm. But like if you're just talking about DevOps is kind of like the model or the ideology of it. I mean, it really comes down to efficiency or productivity within an engineering team or within a project team for development.
So that's kind of where it all started, was people were doing things over and over badly and decided that they needed some sort of rigor.
Yeah, it's about kind of breaking down like barriers or obstacles between different teams, because a fairly traditional model is you've got developers over there, you got operations on the other side at the very least, but you might also have QA and some other departments who are involved. And if they're all on islands and the only way that they can communicate with each other is by putting messages in bottles and then waiting for responses, right? Like things tend to take a long time, So and if those silos, the islands of people are operating separately, where they've all got their own goals, they all got their own priorities, and they're not aligned on what the priorities are, then if development's trying to do something, they need help from operations, for example, and operations is busy doing something else.
Right.
The developers might just have to sit and wait for something to happen,
Or they just
yeah.
So that's actually the fact that you mentioned that. So I think, goodness gracious, what year is it, Peter?
2023.
2 decades ago. 2 decades ago, I worked for a large retailer locally, and I worked in a DevOps-ish role pattern, right? Like I was a WebSphere. Do you guys remember WebSphere? Okay, cool. At least
of course.
You do.
Who could
Peter,
forget?
You won't know this. Yeah. But that was literally the model, right? Like here's a deployable artifact. Here's a WAR file. Here's an EAR file. I'm going to just email this to you sometimes, right? And then make sure, get it deployed into WebSphere, do something with it, right? That was the dark ages, I guess. I was going to ask you guys, like, what would your role have been like 15 years ago or 20 years ago, right? Before you had the tool sets that you have now. Is it similar to what you do now, or would it have been more of a sysadmin, network admin, application administrator, kind of a confluence of all three of those things? What would you call it?
A sysadmin who writes a lot of Bash or PowerShell. No, not PowerShell, but batch scripts, I guess. That's the best way to describe it.
I was saying the same thing. It's like decades ago, there were tools that could enable some of this, like the continuous integration ID, and some of that stuff existed, but they were very immature. But to Seng's point, they're like, and even today, honestly, even with the tools that we have today, a lot of the automation that gets put in place is glorified bash scripts, or bash or batch scripts, depending on what you want to call them. But so you're defining instructions and they run. It's just the tooling around it has gotten more sophisticated and easier to manage and track, and scales better and that kind of stuff. But yeah, I think Singh is right that you probably have people setting up servers manually. But as far as like the repeatable tasks, like we're going to deploy code, so it's check it out from source control. Wouldn't have been Git because it didn't exist yet. Check it out from Subversion. or something, and then use, have a bunch of commands that run to build, and then use a command line FTP client to push the results up somewhere or something like that, right?
True.
Actually,
That would be fun.
You're describing a CI/CD that I built from scratch. Basically that, right? It was CVS. We weren't cool enough to have Subversion yet, but the source control system, not the pharmacy. So CVS, a collection of Jackal, right? This was IBM's implementation of TCL for WebSphere deployments. And it was, you guys nailed it. Like, it was not repeatable, right? It was disjointed from the dev process. It was kind of chaos. And supporting a production environment like that wasn't great. So maybe we can talk about a little bit how, like, maybe walk us through quickly, if you got like a couple minutes explanation of walk through the evolution of how we got from that to what we're doing today, which is, to me, having seen 20 years ago, what we're doing today almost seems like science fiction.
Yeah, infrastructure as code is insane compared to trying to get a script set up to install the same programs on all the servers.
Yeah, I mean, I would say like the tools that are on the market, have come quite a ways. I mean, cloud wasn't a thing decades ago, so the cloud and the idea that there's infinite resources, right? Like, you can stand things up on a whim and shut them down on a whim and be charged only for what you use is it has enabled quite a bit of fun ways you can manage like testing environments and create consistency and scaling and all that. As Peter said, create infrastructure as code, so the automating creation of those resources in a declarative way has been powerful. And even one step down from there, like environment management tools like Chef and Puppet for even if you're working in a more traditional environment, but you want to ensure that what's on the server, like the host configuration, is consistent, and you need a lot, you have a lot of them, and you want to make sure all of them are up to date, and you can push changes out. Like, those tools have been valuable as well. And then just the way that it's all integrating into the development process too, right? Where, as Chad said, like, the back in the day, this was very disjointed, where you'd have developers putting stuff hopefully into source control, and then you might have a different person, like a push master or something, who's responsible for, they've got their set of scripts that they've concocted to make this happen, and they're the ones in charge of that, and they run it, and it goes, and then that person goes on vacation and nothing can happen, right? Because they're the central hub. So the fact that this is all automated through the development pipeline, where you check stuff in, it can trigger these builds automatically. There's visibility to everybody. That code, those scripts or that code is part of the project alongside everything else. So there's more access, more kind of integration with the members of the team in general, and not having so much like this specialization of the roles within the team necessarily.
Yeah, and you also have the idea of like breaking down those silos between the dev and the operations, right? Like, the original idea behind DevOps is a shared responsibility model. Devs would sort of take on operation works, and operation will sort of take on dev works. And yeah, that in practice, I mean, in theory that should work well, but in reality, not really. But just breaking down those barriers, just having a conversation, right? Kind of hard to get a bunch of introverts to talk to each other,
right.
Even now.
The way you were describing it, it reminds me of the commercial where you got chocolate on my peanut butter and you got peanut butter in my chocolate. So it's kind of a funny little, both things doing things not as good as sort of the Reese's peanut butter cups, putting them both together in one spot nicely and perfectly, right? Which is kind of what DevOps is, right?
Yeah, and having visibility, because there was I've worked at places where we have things that are automated. But the visibility of what's coming out the other end isn't necessarily with the whole team. So there's there's people that manage the deployment system, and it does trigger all the way through, and when everything works, it's great. You get a working app come out the other end. But if the build fails, and then it's a lot of, well, who do we need to point our finger at, right? So then the deployment people got to go in there and look at logs. Was it a build issue? Was it a deployment issue? What was it? And try and get so that as soon as something breaks, then there's a bunch of human beings involved. They have to sort it all out, and only some people have access to production. Some people have access to deployment. Some people have access to code. And so, I think that the breaking down the barriers thing is important, where if you have that information and the tools to get all of that information back to everybody, right? So the developer is making a change and pushing, and then it breaks. They should be able to look at the logs. They should be able to see production logs. They should be able to see, the deployment logs and be able to investigate it themselves and make the change, and then fix it and push it again, independently, and not having to wait on other people to gather information for them.
So having that communication go out to everybody, or at least the appropriate people for where the problems happen. So if they occur in build part, then it's probably a developer's problem. And if it occurs in the deployment part, it's probably a operations problem. Something wasn't configured right or something like that.
And making sure people understand it's a team effort. When there's a problem, it's the team's problem, not just an individual's problem necessarily, right? But you kind of, we don't, when certain people only have access to certain things, that's where it's easy to fall into that groove of like, oh, well, I pushed the code and it blew up over here, so it must be your problem, right? I think by everybody getting notified and everyone having visibility, it creates that sense of like, this information is available to everyone, so it's everybody's problem.
To that point, Eric, like I remember some of those days, right? Like I was a developer, but I was mostly invested in like the WebSphere ecosystem. So I was managing WebSphere. I know how to write code. Coming from the mindset of like a early 2000s DevOps type of role, and having those exact conversations with developers, like, hey guys, this is what's broken, and not having really the tightly coupled partnerships that we have today with our DevOps engineers is absolutely, it's different, right? Like it's less adversarial for darn sure these days than it ever was before. And it's just so much smoother. Seeing the DevOps code deployed alongside my own stuff, having a repo for the DevOps stuff right next to what I'm doing, makes those conversations with DevOps so much better, right? Like, hey, I'm deploying this. I think I've exhausted my JDBC pools, right? But I don't think I did. Can we see some visibility? You have that now, and you didn't, 12 years ago, 15 years ago.
Right.
I mean, sure. You did, but not to the degree that we do today. And that's kind of a convoluted example, but it proves the point. Like, it's so much nicer these days than it was.
Yeah, I suppose that's the one area of visibility I didn't mention before too, is like you said, you mentioned like having the deployment scripts right alongside theirs. Is like the visibility of like what's actually happening. Like everybody having access to those scripts is useful too, because as a developer too, like I've faced that where you're dealing with just frameworks in general, and if it's a closed source framework, you don't know what's happening. And deployment can often feel the same way for developers, where if there's a deployment system over there, and you can drop your app in the bucket and hope for the best, but having access to the scripts, you can see what the actual steps are, what's happening, and when things aren't going wrong, the fact that you can help out by saying like, oh, I see why this would be a problem because because the developers have access to it and can understand it and learn more about it.
Let's say I guess we've talked in the past, and maybe this is in the podcast or not in the podcast, about DevOps being a journey, right? That nobody starts at the finish line of DevOps. Even a startup starts with something that's not a fully configured DevOps environment, right? What's the first step, or what's the easy fruit to get? How I came into being a DevOps engineer was in an organization that had none of that. I mean, we were in terms of like sophistication of deployments, we were like cavemen clinking rocks together, and frankly, every anti-pattern for what would make good at DevOps is what we were doing. And it's interesting because we, the way that the managers tried to solve the problems with it only made it worse and not better. So, just as some examples, I mean, in terms of what we were doing, I made a list because it was so vast. So everything was manual, right? There was absolutely no automation whatsoever. So every push was manual. The way that the pushes would work through, so a lot of, in terms of testing, you would go dev, stage, production. Right. So, but the way the deployment, a developer would push manually from their workstation to dev, and then they would copy files from dev to stage, and then copy files from stage to prod. And since each of those hops was not a derivative of source control, you're just hoping that they would copy the correct files along the way. All of the tests in production environments were made manually. Everything was static. So like we had dev, stage, prod, and that was it. If you had more things in flight than that, you just had to wait your turn, and so on and so forth. Honestly, just saying dev, stage, prod is probably a step beyond somebody laptop prod or
true. Yeah, the Yeah, so there was an era where that we were pretty sophisticated just having dev and stage. You're right, and then as the team grew, where you were solving more problems concurrently, it became a huge obstacle. But yes, I agree that just having those environments.
Right.
But there was so much of it that was a single point of failure. There was so much of it that wasn't crazy. Like source control was just it was at the end of the day sort of optional because you didn't need to put it in source control. You just because everyone was just pushing from their workstation and so on.
Nice.
And in terms of visibility, like we talked before, like if something was happening on the production environment, then the developers had to get in there and troubleshoot. So everybody had access to production. Everyone had access to all the credentials, all the secrets, all the everything.
Nice.
So and obviously there's a lot of problems that arose from that. I mean, there's a lot of single points of failure. There's a lot of oops, I deleted this, or oops stuff, or things not getting pushed right, or when developer A pushes, it's great, but when developer B pushes it, there's some stuff missing, that kind of stuff. So to try and fix it, the initial was let's put more process around the process. So they had a push master. You got to submit notes on what to push, and all that happened is became more laborious. The pushes took multiple tries, but it was like where it was this telephone game of like A would tell B would tell C what to do, and it was just slower because you had to copying files wasn't just you just drag it anymore. Now you had to tell someone else to drag the file to the server. So we started talking about automation, and Peter, to your question about where to start, automating any part of that process can be valuable.
That's true.
So and it was funny because the people running the show were not convinced that was going to be a workable solution, and so it was like I hope you all know the folklore of John Henry, where he's driving railroad ties or something by hand, and somebody invents a steam powered machine that does the same thing better. Better than a man, and so it's like man versus machine, and so we did that. We wrote some automation it just followed the same process that the humans needed to do. So it didn't do something different. It just did what they did. And so we ran those processes in parallel where every push we would have the humans do it and the automation do it. And then anytime that we didn't get the same outcome, we would investigate and see who was at fault. Was it the people or the automation? And wouldn't you know it, the people were always the weak link. So
weird.
Yeah. So we went on that, and then it's like, okay, well, this is the process now, so we could take people out of the equation for just this. And all it was just, like I mentioned before, you had to submit notes about what to push. So all it was a thing where you drop a list of files into a hopper, and it would just copy them from dev to stage or from stage to prod.
Yep.
Right. What we immediately discovered was there's some kind of nuanced benefits of automation. Because there's the obvious ones, right? There's it's more efficient, it's more consistent. It's more repeatable. You could do them in parallel, right? So if you have one person in your organization who does all the pushes, he can only do one. That person can only do one push at a time, right? Whereas if you have automation, generally you can have multiple pushes happening at the same time because computers can think about multiple stuff, and it could happen continuously, right? You could build it where it's happening all the time. Whereas generally when you get a human involved, it tends to be we're going to do this prod push, right? But you can have the automation doesn't care about doing it all the time.
Right.
But the more nuanced benefits were what it did was it forced compliance for the human parts of the process, especially the stuff upstream from the automation, because the automation only does what it does. And so if it's expecting input in a certain format, it meant that instead of the notes about what the files are being just a sloppy mess or just ambiguous, it had to be exactly what you wanted to push or it wasn't going to work, right? So suddenly the notes that the humans were writing were better because that was the only way that was going to be accepted by the automation, which is huge. The other thing is, like I mentioned, a lot of this was the developers were doing a lot of the initial pushes even before we had the push master. The process of doing that and all the tools you need to do that and understanding how to get on a server, especially with Linux. That stuff is a big obstacle especially for junior developers, but if you can automate that process away, then it really brings down the barrier to entry for junior developers who are coming in or just new people on a team where junior developers come in, they can just focus on code, building the features they want, and then when they're pushing changes and the automation's picking stuff up and moving it for you, then they don't have to worry about that part.
That is a big advantage. that
it's
people
not that
don't
nobody
really think
needs
about.
right. It's not that nobody needs to think about it. It's that you don't have to have everybody thinking about it when you've got people who are junior in the
Right.
team. Like they can learn that over time as they become more savvy, but they don't need to worry about it on day one.
Yeah. So, Sang, how about you? What's your first low hanging fruit of DevOps to grab?
I bought into this DevOps idea, or I figured out what DevOps was when I was reading. Or what I wasn't reading, but I was listening to an audiobook of the Phoenix Project, the
Sure.
go-to DevOps.
Yep.
And it was describing the problem I was having right now, where this step wasn't automated and it kept getting missed. And I came to a realization, maybe we should automate this too, right? Because this is what this guy did. And so
Right.
it worked for him, right? And so that's what I did. It simplified the process. And then would eventually led me to the DevOps handbook and got me curious about like reading books about the Google site reliability engineering, or the site reliability engineering book by Google.
Okay.
So that's where I start. Like, see if you're running into problems within the Phoenix projects, and maybe we should implement those ideas. Start limiting acts instead of having automation just be about code. Also include tests and security scans and all that fun stuff.
Right. That's another big advantage, right? Is like not only do you write more tests, they run more tests because it's all part of the whole process. Chad, you're laughing.
No, I'm just what Sing's talking about hit about. Like I remember the old days of. I mean, we tried to do like checklist manifesto stuffs, right, for production deployments. Did we do this? Mm-hmm. Did we update NS entries correctly? Did we, configure our pool settings correctly? Did we do all the tuning that we said we were going to do? And we tried to do it by checklist. And we would get it right a lot of the times, but the times we didn't, it would always just be something that modern tech stacks and automation platforms would just do almost out of the box, right? And so, yeah, I remember specific examples of when you don't have that kind of automation in place, when you don't have that kind of repeatability to this stuff,
right.
all chaos that just naturally comes from that. No matter how good you think you are, or no matter how perfect your production deployment plan is, like that's the one thing that I wanted to ask Sang and Eric about now is like modern platforms. I remember. Again, I'm dating myself, but this is forever ago. The production deployment plan was this very rigid, specific document that had, like I said, a checklist. Did you do this? Did you do this?
Right.
Did you do this? Did you do this? And nowadays, it almost seems like that kind of thing is still maybe kind of necessary, but not really, right? Because we've had automation handle this for us anyway. And it's really just, we're going to cut a release build. We're going to handle our CI/CD stuff is going to handle this. And we don't necessarily need to, jump through all these hoops for a production deployment anymore. There are some common sense things that we should do, but like, that is kind of the case these days, right? Or do you guys see other things happening?
People have there's still some type of barrier to prevent people from breaking stuff from time to time. But for the most part, automation, there's still old tech stack that have an idea of DevOps.
Eric, how about you?
Tech stack, and by old tech stack, you for sure don't mean Java, right? Because it's still new and fresh and beautiful.
Yeah. Nah.
I saw you bite your lip. Yeah.
Yeah, I mean the visual of the checklist, Chad, that you're saying is interesting because it still does exist. It's just a matter of how much of the checklist you are automating, and it's not necessary, and it's not saying that you need to do all of it. You can still and I don't think humans are ever entirely removed, because I still think that manual testing, like end user style testing, is still important. So generally, even in an incredibly savvy environment, it would be automate as much as you can up to a point. Human testing, click a button to
and then click a button.
Yeah, and I think a lot of environments still, like you even if you automated right up to the point of pushing to production, there would still be a button that somebody has to push to do that. But like I said, the visual though is like when you're building the jobs in modern tools, you break it down into different workflows and jobs, or whatever vernacular the different platforms have. But that's the way it shows, is just like the workflow is running. It's a checklist. And then as the automation's doing those jobs, it's checking them off. And then if it fails,
right,
then that's the red one or whatever. But that idea of a checklist hasn't gone away. It's just, it's just the steps in a lot of cases have been automated.
Well, yeah. And when Chad, you mentioned the checklist, I thought like that is the precursor. If you don't have a checklist, if you're just doing it, well, this guy always does it right, and we're not going to write down what he's doing, and hopefully he doesn't get hit by a bus tonight. But if you don't have that repeatability checklist, you're going to have a harder time automating any of it, right? Because you're just going to be guessing at different steps.
Yeah, because ultimately, like it works both ways. Where if you have a process, as Peter said, like you have a defined process and you're automating it, it needs to be defined so that you can automate it. But also, if you're looking at a process that has been automated, you should be able to. A human would be able to do those steps themselves as well, right? Like you could always take because as I mentioned at the top of the discussion, they're glorified bash scripts. You could take them apart and just run them locally or manually, and you'd get the same end effect.
I think maybe some of the systems seem to have gotten a little bit farther along than that kind of kickoff based off, I checked in a file and a build just happened because files had changed, right? And it goes all the way to production.
It's entirely possible. I mean, a lot of organizations are afraid to go that far with it. And I've even done it in circumstances where it's an internal tool. You check into the master of the main branch, and it just kicks off a production build instantly because there's little risk.
Yep.
But it's entirely possible. So usually the manual step along the way is an explicit decision to say let's have it stop at this point. Let's have somebody come in and like look at what's about to happen and just make have human intelligence in for a second before it moves on.
Yeah, luckily with the modern tools we have today, there's always like a governance step not step, but committing changes to.
That's a good point. You get a lot of governance into your CI/CD pipeline just because you're doing all of this, right? You can put those checks and balances in as part of automating things like send an email or send a Slack message or send a Teams message and have somebody approve it, or stop at this step and wait for magic to happen, right? And it's a governance that might not have existed. It's a governance that didn't exist 10, 15 years ago because none of those systems that I just mentioned, except for email, existed back then.
All right. So, who's all right?
I was saying and some of the roles we mentioned too haven't gone away, but they've definitely changed in terms of what you're responsible for.
Oh yeah,
because it's more about, instead of like necessarily being the only one who understands it and does it, it's that you're ultimately responsible for that it's working correctly and being like implemented correctly. And to Sing's earlier point about the importance of limiting access. Then that's the only reason you can implement governance, because if people literally don't have access to production, then they can't go in there and start working around the process, right?
Yeah, and I mean, honestly, credentials are not even something I even think about in a lot of cases anymore. I don't need anything but my own credentials because the DevOps system is going to put in the correct credentials along the way, and it keeps them secret and takes that management out of human hands and makes it better.
So that plays into something that Seng told me once too, because somebody was asking advice if they wanted to get into DevOps, like as a developer, like what would the transition look like, and talking through it, at the end of the day, you might need to get onto a server or go into a Docker container and know the command line stuff. And what did you tell me? I don't know if you remember that discussion, but
I don't remember that discussion.
Yeah, your advice is like, well, if you have if you have the log aggregation set up, like in AWS for Docker, if you got CloudWatch set up, then what you would need to, right? It's not important. So
just repeat what they said.
Which brings me into my question: like, how do we screw this up, right? So. You guys have, as you guys have been doing this for a while now, we've certainly developed some like shortcuts and anti-patterns in the DevOps space that you want to avoid, right? Do you have a greatest hits list of anti-patterns?
Mine's is having a human as a single point of failure, right? You have this super, like he's the hero that you need, right? Not the one that you really deserve at the moment, but yeah. And we also
Batman reference.
Yeah, Batman. But you don't want to do the task that he's doing, and he just says yes to everything, does everything, understands how to spin up the server, understand how this procedure works, right? But one thing that happens comes the bottleneck knowledge sharing that's happening. Either the workflow slows down, or if worst case scenario, he leaves, no one's there to replace him, right? Or no one's there to pick up the job. Automation helps with that, but also there's the human tie his hand and you spread the wealth, right? That's if we don't do something like that, it's a lot of problems.
So just the superhero, the one case where the Avengers don't work, right?
Yeah.
Yeah. Okay.
I mean, what I throw out there is there's a lot of tools that can help, but it's easy for folks without experience with those tools to implement them just completely wrong. Like there's lots of shops that don't they're using Git, but they're not using even a tiny percentage of the feature set of it. You have source control, but they're not using it for any sort of governance or process. You're trying to use infrastructure as code to deploy applications when that's not really what it's designed for. Docker is a good example too, where like I could talk for hours about how Docker is transformative in the space, and it's the best technology that I've seen in my career. But most teams where they go to implement Docker for the first time do it all upside down and backwards from how it's really intended to work, because it just takes experience to understand those things. So making sure that you have somebody there who can help guide that, who has the experience, who has done it before, can go a long ways to saving you a lot of time of going through and implementing the whole thing only to find out you did it completely wrong and then have to start all over again from scratch.
So tell me the Docker anti-pattern that you're talking about. What, like my first foray into Docker, I'm going to start it tomorrow. What am I going to do wrong?
So in an ideal circumstance with Docker, it does it the pattern it tries to force, but you can work around it, is the idea that you're splitting application from the data that it manages. So any sort of persistent data, like a relational database, uploaded files, that sort of stuff, like that's independent of the container that you're going to run, and the configuration, right? So if you're going to deploy your application on your local workstation, on a dev environment, a stage environment, production, right? It should be defined how you would what those configuration points are that separate those environments. So working locally versus stage, there might be a different database you connect to. So you need to be able to pass in those parameters as typically as environment variables, but have some mechanism for configuring those things between environments. But that aside, you should be able to use the same image for every environment, right? So you should be using the same exact Docker image locally versus production, other than how it's configured. And I've seen teams where they need
30 Docker images to cover all of my different scenarios.
Yeah, or they'll just bake all of the configuration into the Docker image and then they're just like picking between them. So all their production credentials and everything are checked into source control and
nice
and baked into the Docker image and stuff like that. So yeah, you could definitely cut against the grain with Docker pretty easily. Plus, there's a lot of misunderstandings I've encountered around things like Docker Compose, which is really meant to be a human aid, right? So like you can define, if you were going to run it locally, what the relationship is between some different containers and what the configuration points are as a human aid, but sure. It's not meant to be a deployment mechanism, because I've seen projects where they go on the server, they check it out, and then they do Docker Compose up, and that's their deployment, and that's really not what that tool was intended for.
Okay, interesting. So
I was going to say, one of the biggest issue or anti-pattern with Docker containers in general is that people don't understand what they are or aren't taking the time to learn them, which is also, not reading the manual is probably a big anti-pattern, but that's a different conversation. But yeah, for most people, they see Docker as spinning up containers, or they can see containers as lightweight VMs, right? That's the answer that most people give, right? But it's not like them. It's like this. At the end of the day, it's a Linux process, right? It's on virtual file space, all the dependent. But most people treat it.
So I'm going to spin up tiny VMs to do the things that I want, when really I should be spinning up tiny processes that only do the parts that I need. Interesting.
Yeah. It's a good point, because an example of that is where that goes wrong is when people try and bake multiple processes into the same image. Right, they're trying to run. They treat it like single state as a virtual machine, where they put MySQL in there, they put their web app in there, they got Apache in there. how do I get cron into my Docker image? They try and bake everything into one image instead of like focusing on making each container a single process, a single application.
So instead of siloing on this is my application's image and all the pieces that needed for that application are in that image, it's really I should have all the things separated by parts, not database and not the virtual machine that I would spin up if I wanted a tiny application.
Right. And obviously you need the runtime dependencies. So like everything should be in there that it needs to run that process. Sure. But I think, thinking about it at the process level, like Singh said, is I think that's important.
One thing I don't really like about Docker is that it took the name. Everybody calls it Docker. I don't like Docker.
Yeah. So does the
tissue?
I was gonna say, is that does it happening in other markets frustrate you too? Sounds like it does.
So let me ask this question: Is one of the Docker anti-patterns getting once I get Docker running, I'm done, and I got my app running in Docker, so I must have done everything right?
I mean, there is the anti-pattern of where you're doing no maintenance. Because that which is not unique to Docker. Obviously, a lot of people, they deploy something and then, it's running, don't touch it.
So vulnerabilities always jitter when it comes to like a running container. Once you get it up and running, right? Like at the end of the day, a file space has libraries, all that fun stuff that could be vulnerable to attack.
So if I'm a company that's running just everything local, I don't have any cloud stuff. Do I need DevOps?
It helps, right? Like the concept. The idea behind DevOps came prior to the cloud, right? It's just automating structure at the end of the day, trying to eliminate human errors as much as possible, just so you can have a normal conversation with people and collaborate. That's it.
It's not a linchpin in the process in terms of you can't operate without it, but it serves to take the human resources that you have and make them considerably more efficient than they would be otherwise. So it's an ideology that focuses on that efficiency or focuses on that productivity. So if you like having non-productive people, then you certainly don't need it.
When is it too much? Like what are the things that DevOps folks tend to overcompensate for, but like there are, I think I've seen things unnecessarily automated that don't necessarily need to be. And this is more of a process thing, not necessarily like specific tech stacks, right? But you guys had that experience where like, yeah, we're going a little too far with this.
Oh yeah, I've over-engineered stuff before.
Yes, I guess that's what I'm asking. Have you guys over-engineered the hell out of something before? And how do you know like you've gone a little bit over the edge?
How do you know when you introduce someone new to the process that you created? Yeah. Do you understand this? No. You read this workflow file? Oh yeah, but it's really, really, really long, right? That's how you know where you've gone too far. I tried to make things as simple as humanly possible, right? Like I lived by a quote by a guy who helped write the Unix operating system, and then he infamously said that troubleshooting is twice as hard as debugging. So if you write the smartest code you ever written, that definition, you're not smart enough. So I try to keep things dumb.
Keep it simple. How about you, Eric? Overly engineering anything lately or in the past?
Yeah, I mean, we actually ran into a case of that this week where me and a colleague were working on trying to deploy something, and we ran into a like a chicken and egg sort of dependency issue where we're trying to stand up the infrastructure with a script and then try to deploy the application with the script, but you couldn't deploy the application until part of the infrastructure existed, right? So one had to come partway before the other, and the initial solution that we talked through and got put in place. And then when I was reviewing it, I was like, this just doesn't like pass the sniff test of like keep it simple, stupid. Or both scripts that what got put in place was where halfway through the script it would stop and wait until the thing that the other script needed to do.
Nice.
And so, but the actual like implementation of like how that would happen was just like more complex than the entire deployment script otherwise. Right. So it's like, so it's just like one of those things like, yes, this works, but it just feels like we're off the path or we've gone too far with some of this. Like there must be an easier option, right?
If everybody has to synchronize their watches or every script has to synchronize their clocks at the beginning and run at the precise time, it might be a little complicated, huh?
Yeah, exactly. So yeah, so we just took a few steps back and just I mean the solution was so much simpler of like, let's just have one script that does the first half of the infrastructure, then deploy the app, and then do the second half, right? Like just have those three things run in sequence, and then we don't have this dependency issue.
I was thinking the very same thing, surprisingly.
Yep.
Like, hey, what if you just split it in half and made two?
Yep.
Nice.
It worked perfectly.
Chad, anything? You look like you're thoughtful.
No, I'm just walking through, like, in my head, all of the DevOps mistakes I've made, right? And I think one of them that I've done is, prior to consulting, I was in a tiny shop, right? And we all kind of shared that DevOps role. And so we would, and we were using
F.
Yes, I was talking about this a little bit ago. We were using Chef, but we were using AWS's implementation of Chef called OpsWorks. And that tool didn't necessarily lend itself to super slick automation. It was better than nothing, right? But it wasn't obvious. It wasn't perfect. And I think one of the things that I found is like really not having that dedicated role, trying to share that responsibility with a bunch of folks that aren't all in on it is my anti-pattern. It is so much nicer to have like a Sang or an Eric, or on my team, I've got my friend Chris Tollefson has been a godsend to the team as far as like understanding this technology, being intimate with the tech stack, and being able to like enunciate things that, in that headspace that we would only kind of skim the surface of. Right?
Sure.
So dedicated resources to this that are all in on it. Wonderful. Perfect.
So part-time DevOps is sometimes worse than full-time.
I think part-time DevOps is better than none at all, right? You get some repeatability built in there, but part-time DevOps versus full-time, like if you can have a guy,
I think you need more than one person because.
Well, yeah. I mean, so saying, that's a good point. Like you need to have a fallback guy if you can. A redundant array of inexpensive DevOps engineers would be phenomenal. But for smaller companies, at the very least, have one, right? And then solid documentation.
So
Well,
is that radar?
I was gonna say that just have one guy could lead to burnout. Like it's hard to. Sometimes you don't account for the human factor, right? So much that only one person can put in the whole brain, so it all explodes.
That's an interesting take on things, to like not just have one super focused person that knows everything about everything, and then their brain explodes. That's a bad thing,
right? Like I think I remembered that it happens to me a lot, right? Where I end up. Or like the container platform, previous company, and it was just over and over again where we were just dealing container platform, right? Because at the end of the day, no one really knew how, and spreading the wealth was kind of hard. Everybody else was specialized in their own. You're trying to make improvements while this tech stack, or not tech stack, but work keeps getting pushed onto you because you need to put out fires while you're also trying to build the ship too.
Put out the fires as you're building the ship. That sounds complicated.
Yeah. Well, I think you're right that there's a bit of a trap there with being a DevOps engineer. Oftentimes, where you're coming in to consult to try and teach the team new patterns, new processes, new tools, but then you end up just owning the execution of those tools as well. So there's definitely some value in raising up the team that you're trying to consult with to help them learn the tools and understand it and be able to work within it. They don't need to be, godly experts of it necessarily. Like you can still help troubleshoot, but the day to day that Singh is describing can happen where you come in and say that here's how I think I can make things more efficient, and then they say, great, you do it, and then you own it now, and then now you're stuck with it.
That's true,
Peter.
Well, I think the DevOps engineer being the fallback guy would be the ideal situation. If the team is able to integrate the tool into their process and somebody there owns it, and then then if they're running into problems, you're the fallback guy. That me is ideal.
No, you need another DevOps help you out. That's what I should have
said. Honestly, that was the way on my last project was kind of like that, where the developers had some knowledge, but also had a DevOps person to like, hey, I have no idea how to do this. Can you help us? And like, here's an example. Okay, I can extend that and make it better and tie it into my code and my process and make it. Chad, what were you going to say?
Well, Peter, I was going to ask for any parting thoughts if you had any, because it was getting to be towards time.
It is time.
But you usually do this. So why don't you ask the question and then
Chad, any parting thoughts?
Not really. I think the worst case scenario with all of it. I mean, just have something in place, right? Trust people that have done this forever when they tell you that having just a checklist and a manual process in place is going to lead to catastrophe eventually. You're going to get lucky a lot, but you're going to crash eventually, and it's going to be horrible.
Nice. Sang, how about you? Parting thoughts? Okay.
Just
Eric?
keep learning. That's it. Like the main goal of DevOps is just always learn from your failure.
Yeah, I would say if you're looking to do DevOps, I would try and look at what the patterns are for the platforms you're working on, right? There's a million tools out there, but some of them fit well with what you're trying to do and some of them don't. So look at what the existing patterns are, what's popular, what is recommended. The thing I always go back to is if you're having a problem and you're Googling it and nobody else has ever had that problem before, you can't find it. It's not the tool, it's you, right? So you should always look for if there's a large community around something, there's a large community there for a reason, right?
I will have my parting thought be ask an expert, and we have two experts here right today, and perfectly good. And start somewhere in the pipeline. There's a place that you can start.
And don't believe Shane when he tells you he's not an expert, because that's nonsense.
I'm an expert at getting humble. I'm an expert Google searcher, but other than that.
All right. Well, we appreciate your guys' help today getting this podcast going. Again, thanks again, Eric and Sang.
Mm-hmm.
And it's time to say goodbye, everybody.
Solution Design Group is a digital product consultancy in Minneapolis. Check us out on the web at solutiondesign.com or look for us on Facebook, Twitter, LinkedIn, and Instagram at Solution Design Group.